All right. So this is why I spent a whole separate day on division of radicals, because they're a little more complicated than just the multiplication. Now, remember that property where if I'm multiplying under the same radical, I can split them up and I can go either way with that. That same thing holds true when I'm dividing. And so if I have a radical, I can do the square root of the top and the square root of the bottom dividing. But here's the issue with this. I need some different colors if I'm going to write on. I cannot leave a radical in the bottom. Right there. Well, that's right there. Right there. It's in the middle of the other building. We conquered Rip. Will caught her, and then Will got too scared, and he had the photo. I literally just started. All right, so I can't have a radical in the bottom, okay? So what do? I have to get rid of it. So to get rid of it, if it's just that radical in the bottom, what I want to do is multiply, and we did this when we did, do y'all remember rationalizing the denominator this way? No, never. Yes, I am. No, never. He's mad because he got in trouble. I never got in trouble. Is he coming up here? Right, if he comes up here, bro, I'm destroying them too. Will's the one that called him. Grayson, they really can't see. I really like, okay. Okay, just give me. He's moving. Even though he's trying to be a big old jerk. Multiply those two. All right, yes. Now, this is what we did prior whenever we were talking about radicals. Yes? And so a lot of what we're going to do today is more of simplifying things and putting things together. So, for instance, if I have 12 times the square root of 160 times 2 times the square root of 5, then what I'm going to do, or I'll give you all a second to copy that. I could go through and rationalize this using this property, but instead what I'm going to do is I'm going to simplify what's outside of the radicals first. What's 12 divided by 2? 6. And then what I'm going to do is I am going to put both of these under one radical. In other words, what's 160 divided by 5? 32. Well, 5 goes into 16 3 times. I'm telling you. All right. Simplified, exactly. So what I want to do is I want to split this up. What's 8 and 4? No, bigger. 16 and 2. So that gives me 6 times 4 times the square root of 2, which is 24 root 2. Easy, because that's square roots, right? Let me throw in some other roots then. Okay. Yeah. Oh, don't worry about that. I was just showing them how we were dividing. We did the square root of 160 over 5, and we did 160 divided by 5. All right, so this is what we did in Unit 1 when we did quadratics, yes? So it might feel like you've done it before. The difference now is we're going to throw in. Whoa, how did the board do that? we're going to throw in some other roots. I do the most.
Did you go to National Harvard?
What?
I do the. You went to Harvard?
Harvard.
You went to Harvard? Yeah. So where did you go to college?
It's a substitute college.
Simplify the coefficients first, then simplify the radicals. So somebody said 7, and they're bless you. They're absolutely right. Bless you. Bless you. Simplify the radicals. So 28 divided by 4, you're right, is 7. And now what I'm going to do is I'm going to make these under the same radical here and just simplify them. What?
How'd you get 7?
So now I've got the cubed root of, I should do that in blue. Negative 16 divided by 2 is what? Negative 8. M to the 6th divided by m is, and now I simplify. Why isn't negative 2? Well, the cubed root of negative 8 is negative 2, right? So I got 7 times negative 2. And then what do I do with these?
3 goes into 1.
M squared. I mean M1 out there.
M
squared in there.
And there's 2 left over. Oh.
You can multiply negative 2.
Yes, Stacy. Golly.
Come on, say.
Now I'm done.
Only rainbow.
I got 9.
I gotta take my dad for real. He texted me and asked if I was at school earlier. I'm not texting him.
All right. Yes or no? Pretty easy.
Pretty easy.
Yeah. This 3 and this 5.
Yeah, Will Clearwax, right?
It goes in 5. Don't go from 1 to 3. 3 twice is 6. 4, 5.
I went to Francis Marion, then USC, then back to Francis Marion, and then back to USC for my master's.
Hold on, what?
My dad went to 2 schools.
My mom had it in her and my mom got it out last night. Because I tried to get it out even when I was infected.
I had to get my kids out sometimes.
It was infected.
I don't know.
She had to like dig it and it was like bleeding.
Tiffany had to go to the podiatrist one time and have it cut out.
Okay, stop.
And I
Are your
have
shoes
bandage
too
on it.
tight? Are your shoes too
It's
tight?
probably my cleat.
Probably.
And I did have toenails when I was born because I was screaming. So they grew in weird.
Wait,
What?
True story.
All right. Back to the rationalizing part.
I wear a helmet when I was like everything I big on my neck.
Simplify. 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 Simplify, Grayson.
You ride bow-legged or athletic? Except for y'all.
Except for work.
Except for y'all.
Except for work.
What am I gonna do? Some of you are looking at me who are actually looking at the problem going, wait, what? I can't do anything. So I can't simplify anything as is. I might could simplify this 12, right? Square root of 12, I could simplify 4 and 3, which would be 2 root 3. So technically I could change this to 3 times 2 times the square root of 3. Which is 6 root 3 over 4 root 7. And then I could even do 6 and 4. I could simplify that a little bit, right? 3 root 3 over 2 root 7. But you just go, well, wait, there's not really anything else I can do. But I can get rid of that radical in the bottom. Okay, and we're only, for the sake of this class, we're only going to do this with square roots and not with bigger roots. We're not going to rationalize the cube roots and stuff. Because when you go to pre-cal, we'll do a little bit more. All right, so here's what I'm going to do. I need to get rid of the square root of 7. Some of you have already said, oh, just take the square root of 7 to the top, right? So I do square root of 7. Hey, look, it's Christmas colors. Because up top, this is going to be 3 times the square root of what? 21 divided by, well, what's the square root of 7 times the square root of 7? 7. The square root of 7 times the square root of 7 is 7. So that means this bottom becomes 2 times 7, which is 14. Can I simplify the 21 and the 14? No, because the 21's under a radical. So I stop there. Okay, now let's crank it up.
That was
I don't think I can crank it up anymore. My crank up.
See, I'm only cranking it up.
We've technically done this.
I'm gonna have to get my toe after. That'd be funny. Imagine. Only had 9 toes.
Deion Sanders has 11 fingers.
Deion has like 2 toes.
Right, he's got 4 on each foot. You heard me, Grayson? Huh? There was a Kentucky football last year that had 11 fingers.
That's a lie.
Look him up.
You're lying.
They're not being serious.
What do I do? We did this with with quadratics. Let's see if you remember. You're close.
Use quadratic formula.
Quadratic.
You're very, very, very close.
Well, wouldn't it be 4?
It's the whole bottom, but there's one little thing different.
But leave the square root of 7 on the bottom.
You have to do -2. Get this back.
What? Click my picture. It'll take you to where I am.
Wait, yeah, why is your mirror board white today?
Yeah, right up here.
That's me, why is the mirror board white? Wait, why is it negative?
Because whenever, yes, because this is what we call the conjugate. Y'all remember that?
Yeah, it's the exact opposite.
It's everything's the same except the middle sign. What's your question? I'm writing question. You have to multiply by the same thing top and bottom. The bottom is the only place that you worry about having a radical. Like, I can't have a radical down here. I can have one up here, but I can't have one in the bottom.
Oh, I just got squirted.
It had a 3. Because you only multiply by what the radical is. You don't multiply by the 2 also. You could, you just have more simplifying to do, but you only multiply by the radical. But when you're adding or subtracting, you have to do the whole thing. The other was multiplying. All right, start foiling. Mark, set, go. Boy, y'all better get on my nerves today. Start foiling. Take one, pass it. Yeah.
That's Bella's water. Wait, does that mean Bella did? Oh,
All right, look. Let's go through some foiling here, okay? Let's do the top first. 3 times 2.
6. -6.
Here, whenever I'm multiplying, right, it's You multiply the numbers in front, and then you multiply the radicals. So there is no other radical, so it just becomes minus 6 times the square root of 7. Now go to the next one. Plus 2 square root of 7 minus, this has got a 2. No.
49.
Which is 7. So minus 2 times 7. The square root of 7 times the square root of 7 is 7. All right, let's clean up the bottom. Yes. Square root of 7 times the square root of 7. Yeah. All right, on the bottom, 2 times 2.
4.
Minus 4 times the square root of 7 plus 4 square root of 7. Uh-oh, I see something happening here. Minus 4 times 7. All right, so let's see what we have here. These two cancel. This is actually 14. This is actually 28. So let's look up top first. Numbers 6 and 14 give me what? 20. Negative 6 root 7 and 2 root 7 are like radicals. Negative 4 root 7.
That's in front of the radicals. Can't combine that. It's not like her. The radicals connect.
Wait, was this a plus or a minus on the end? That was a minus, y'all. That's not 20. 6 minus 14 is negative 8. What's 4 minus 28? Now, be very careful when you simplify these. You can simplify the coefficients, you can simplify the numbers, but you can't mix up with the radicals there, okay? So if I find something that I can divide this, and this by, then I can. But leave that radical alone. So y'all say 4, I say negative 4. Because everybody's got a negative sign, right? So, oh, it's okay. Six minus 14. You do the same change. Be negative 8.
2 plus square root 7 over 6.
No, it's just 2 square root 7 over 6.
Plus 2 plus 8.
You can't the radical things in there.
If I take a negative out, I end up with 2 plus square root of 7 over 6.
Nice.
The only other thing you could kind of do if you wanted to would be to split this into 2 separate fractions this way, and it would cause this first one to simplify a little bit. You do not have to do that. I just wanted to make sure I showed you that that's done.